I want my data and I want it now and I need it seamlessly. I don't want to be messing around with connecting to this hotspot and that hotspot. And I want it to be very reliable and I want it to arrive exactly when I need it. So that's a big challenge right now, I would say, for the current 5G.
That was Muriel Médard, an information theorist and electrical engineer who is the Cecil H. Green Professor of Electrical Engineering at the Massachusetts Institute of Technology, renowned for her research in network coding. Muriel is joining me today to demystify 5G and all the buzz surrounding it. Welcome to Capital Considerations, the market and economic podcast that's fully invested in your success. I'm your host, Tony Roth, Chief Investment Officer of Wilmington Trust. The rise of 5G, or fifth generation cellular technology, is all over the news, popping up in conversations surrounding internet infrastructure, safety, the rise of smart cars, even the cost of the next iPhone. But when we take a step back from all this excitement, what changes are we actually waiting for? And what do they mean for our ability to communicate with one another? Today, we are honored to be joined by Muriel Médard, a member of the U.S. National Academy of Engineering and the National Academy of Inventors. She leads the Network Coding and Reliable Communications Group Research Laboratory for Electronics at MIT, where she also studied, receiving 3 bachelor's degrees, as well as her master's and doctorate. She has won countless awards on her research and publications in communications, networking, and information theory. Dr. Médard, thank you so much for being here today.
Thank you very much for having me, Tony.
So I want to remind listeners before we jump in that any information that Dr. Médard provides today is not investment advice. They are insights from an industry expert in the technology space. Dr. Médard, why don't we start with defining some terms? What exactly is 5G? We had, of course, 3G, we had 4G. Isn't this just another incremental step forward in terms of the speed of our phones? It feels like this time it's a little bit different. People are more excited about 5G than they were about those prior generations. What's the difference this time?
That's a very good question and one that I get very often, Tony. So to some extent, 5G is indeed just what comes after 4. But there are some differences between the transition from 4G to 5G relative to the transition, say, from 2 to 3G or 3 to 4G. I'd like to start a little bit with a differentiation between the formal versus the informal definition. Let me start with the formal one because it's a little easier. So 5G is the next generation of standards for what we would call mobile or often cellular telephony. Within that, there is a body called 3GPP, which is formed of major players in the current mobile world, particularly cellular world, and then they got together and they agreed to some standards. There's a different version of 5G, which is what I'm going to call the informal definition. And I think the informal definition is what has a lot of people excited, as you mentioned. And that's a definition where you have truly ubiquitous communications, seamless, with very low delay, what's often called URLLC, or ultra-reliable low-latency communications. So something where you might be able to have services such as haptic communications around being able to have remote feeling, or, maybe at a somewhat closer term, very accurate robotics or automotive, sort of really critical, mission critical infrastructure style services that are supported by 5G. So what this means is, to some extent, both a matter of looking currently at the kinds of services that are being offered, often with just higher bandwidth, better throughputs, and also looking at the future with the kinds of services that people are hoping for or predicting, such as helping with self-driving cars, helping in healthcare, et cetera, et cetera.
So using a car metaphor, perhaps, maybe 2G was a 10-mile-an-hour car and 3G was a 30-mile-an-hour car and 4G was a 40-mile-an-hour car. 5G is almost like a 150-mile-an-hour car, and it's one that goes from 0 to 60 in 2 seconds. is something like that. It's really a quantum leap, if you will, not just in speed, but in this idea of latency.
Well, it's interesting. That's definitely the hope. But actually, you're bringing up the speed as a really, really good comparison, because if you think of roads, it's not just about speed. When you make roads, you don't just want the roads to allow for high speed. You also want them to have enough lanes. You also want to be enough of of roads such that you have a good network, a good connectivity, so that you don't have areas that are really difficult to get to, or you have to use basically a gravel path to reach. So it is very much something where you're trying to expand the type of transportation so that you can have pretty wide roads everywhere. And a lot of that has to do, for instance, with expanding things like the spectrum that you use. So mobile telephony uses spectrum, as does, say, Wi-Fi. One of the things, for instance, that makes 5G special is that if you look at the standards, it's the first standard where 3GPP is saying, well, we realize that you're also going to be using non-3GPP technologies, which really stands in mostly for Wi-Fi. Now, what's happening, for instance, when you look at spectrum with 5G, many of the listeners will have heard that there has recently been, for instance, an auction, which I think brought close to $90 billion. So we're talking about major money in terms of people securing rights to spectrum. But some of the spectrum that's being used is at very, very high frequencies. Basically, you can think of spectrum as just, notes on a piano, and we've been working all around the same octaves. And there's some octaves at really, really high frequencies that we haven't really been using. And those are tricky octaves. Going back to the comparison to roads, you have a lot of space on those roads, but it's full of potholes, and they're really, really difficult to travel on.
So I want to ask a bit more about these standards, because as a layperson and as a consumer, one of the things that's been frustrating is I've read a few articles over the years, last year or so. The idea of this 3GPP would suggest that there is, for the first time, some type of uniformity in what you get when people say they're offering a 5G service. But from what I've read, it seems like there are different levels of 5G, and everyone claims to have the best 5G, which is different than everybody else's 5G. So what's the reality around 5G? Is it really the case that if I have quote unquote 5G on my phone, it's really 5G?
I think that you make a really good point, Tony, which is 5G is a lot messier and a lot more heterogeneous than the previous versions. I'll give you an example going back to that piano analogy. If you think of what was going on in 4G, pretty much everybody was working over roughly the same octaves. Even more that the case in 3G. Now, when you're looking at 5G, it's like people are not even all using a piano, right? Everybody's using different instruments. And strictly speaking, it is 5G. It's all under the same umbrella. But in practice, you're looking at really, really different technologies with super different performances and also very different costs of deployment. I mentioned those high frequencies, the piano octaves at these really high frequencies. What happens is just like you do when you're playing an instrument, you notice that the very, very extremely high frequencies are not going to carry quite as far, right? But it's, if you hear, say, a car with a radio on some distance away, you pretty much only hear the bass, right? The boom, boom, boom. It's not because the music is all bass. It's because that travels further. Those lower frequencies travel further. Some carriers are deploying 5G at very high frequencies, which means that because it doesn't travel as far, you may need to do different deployments of hardware. Some of them have actually gone to lower frequencies than what we saw in 4G. And all of them are using a whole lot of Wi-Fi. Even your current 4G service, I would hazard to guess, Tony, that you use your phone with Wi-Fi more than you actually use it with your 4G carrier.
So let me ask about that. And I think that part of it seems sort of intuitive to me, if I have it right, which is that when you say they're actually using Wi-Fi, I'm sitting in my home and I'm talking on my phone on a call with you today, Muriel. You don't mind if I call you Muriel? I know, because
Of
we've already
course.
spoken several times. Okay, thank you. But I actually initiated the call with my cell phone. But in reality, because my cell phone is connected to my Comcast internet, the call is actually being carried over Wi-Fi. And so even though I'm paying Verizon probably to make this call, even though I don't get charged minutes, it's part of my plan. They're somehow using the Comcast Wi-Fi to make the call. I get the benefit. It's probably even more clear and more stable. But does Verizon pay Comcast for the privilege of using the Wi-Fi over which the call is actually being carried? How does that work?
So you're opening up a very interesting, I was going to say can of worms, but let's say at least topic, which is that a huge amount of traffic, and it's assumed that at this point 4G is already mostly carried over Wi-Fi, is being carried over Wi-Fi. Now, Wi-Fi is also having its own different versions, and it's also being progressing. The Wi-Fi that you have in your house now is probably better than the Wi-Fi that you had, say, 10 years ago. Generations in mobile communications, these different Gs that we talk about, tend to come at around 10-year marks, roughly. Used to be, to a large extent, that it was kind of tied to retiring equipment, sort of the obsolescence of equipment, or, basically you had to fully amortize your equipment. It was time to buy some new equipment. And in previous incarnations of the telecoms industry, there were some really strong regulatory reasons why upgrading equipment very often was actually beneficial. But the Wi-Fi industry has also been progressing. That one is not at all under the purview of 3GPP. So 3GPP, as I mentioned, is really a very closed club. So Wi-Fi is actually run by IEEE. I am it's the Institute of Electrical and Electronics Engineers. I'm a fellow of that society. And some of you may have heard of Wi-Fi as 802.11. I don't know if you've ever heard it called that. It's 802.11. It's actually, that's the name of the standard in IEEE.
So is 5G, I know there are different versions of it as we've discussed, is 5G essentially as fast as 802.11, the average 5G? So that if I am home and I'm on the Wi-Fi, but then I migrate someplace else that doesn't have access to Wi-Fi, my device will automatically switch to 5G, and I'll experience a similar level of speed and bandwidth that I would have if I was home connected to my Wi-Fi. Because if that were the case, I could understand why 5G would be so important, because it would be essentially providing the quality of connectivity that I have when I'm sitting at my home on Wi-Fi much more broadly.
Yeah, so it really depends on the service provider and where you are. I would hesitate to talk about, an average 5G at this point, just because the deployments are very incipient in some places. And as I mentioned, they're really taking very different forms.
But that's the goal, I suppose, right?
That is the goal, yeah. I should mention, a really interesting development in Wi-Fi, which was announced, but it was funny. I barely saw it mentioned in the news. And to me, it looked like such a big deal and potentially very impactful in terms of technology, was that. So basically what happens is there is a Wi-Fi alliance formed of multiple companies, and then they come up with, in effect, if you will, sort of a recommendation, and then it's IEEE that I mentioned before that really sort of pulls it together and cleans it up. And the Wi-Fi alliance works pretty fast. I would say generally much faster than 3GPP. And they actually went ahead and said, hey, we want to allow roaming. So what would roaming mean? It would mean actually that you could not have to do the really clunky current signing in all the time when you go from one Wi-Fi hotspot to another, and that you would have roaming in the same way that you have roaming with your phone. I actually don't know what the consequences of that are, but you can imagine right away that might really mean a very big competition.
Whenever I leave my house, I seem inevitably to not be able to connect to the internet. And the reason I can't connect to the internet is because my phone connects to a hotspot through Wi-Fi that the cable company provides. But that hotspot, in fact, doesn't actually have any bandwidth on the internet. It's not working correctly. So I have to turn off my internet when I leave the house so that my 5G operates.
That's exactly it. You just described the problem perfectly. But of course, that's actually not a problem that's technically that difficult to get around.
Because the cable company is too cheap to invest the appropriate resources in their Wi-Fi nodes so that they actually have the appropriate bandwidth for all the people that are connecting to them.
Yeah, in some cases, actually, what companies have done is they have given incentives to their customers, particularly in urban and fairly dense suburban areas, so that they can use customers' spare Wi-Fi.
Right. I have that on my gateway. I can turn it on or off if I choose to.
Exactly. Yeah. And that also has, it's sort of taking off more in urban and suburban areas, particularly the Northeast in the US. It has been around for quite a while in a lot of Europe. And actually that gets us a little bit to the next question. It's like, okay, you've just identified the problem. Everybody knows this problem. Everybody's aware of this sort of bizarre coexistence between Wi-Fi and 5G/4G. One of the things that's going to happen is eventually when you have these kinds of inefficiencies, somebody's going to come in and fix them, right?
In other words, why do I pay Verizon $300 a month for my family to use their 5G network when 98% of the activity is actually happening over the Comcast Wi-Fi network? Does Verizon pay Comcast anything for the privilege of using their Wi-Fi and their system in order to route all their calls?
I do not believe that is the case. But of course, I'm not privy to agreements. But generally, I don't believe that's the case. I'm basically allowing my phone, and sometimes it's even app dependent, to join only by Wi-Fi and join only by phone, or to transfer to Wi-Fi, because I know that I make calls on my phone when I'm not at home, and on
right.
friends' Wi-Fi hotspots, and I can't imagine that they track.
So the 5G providers, the cellular providers, have a pretty wonderful business model at the moment because they don't need to build up a system that can handle the bandwidth of what their customers are really utilizing, because most of that bandwidth is going over the Wi-Fi and the internet directly. So how will the industry adapt to that? Will there become a provider that allows me to only pay for bandwidth when I'm outside my home, so that when I'm in my home, I can just use the Comcast and I can save a lot of money?
So you can imagine the possibilities entirely there, right? But you're going to need somebody who's doing the engineering and doing it over the top. I mean, the traditional service providers in the US have what they've called de-skilled over the last decade or so, certainly since 4G. That's to say that they've really outsourced a lot of their engineering to the companies that provide them their equipment, the Ericssons, Nokias, Huawei's of the world. And it may have been a solution that, made sense at the time. But it's certainly right now, I think it's a risk. It's something that I think the industry has realized is a risk. And I'm not just saying that because, of course, I'm an engineer and I think everybody should have, lots of engineers on their staff. It really is, something which you don't need it until you really need it, right? So I think that it's going to be a very interesting period of time to see what happens. A lot of the research that I do is actually about being able to use the Wi-Fi network and the mobile network, say 4G or 5G, simultaneously optimally. So maybe using all of the resources that you have and combining them optimally rather than sort of switching back and forth clumsily between one and the other, and sort of just connecting to everything that you can connect to at a time and just merging all of those services in a seamless fashion.
What companies do you think are apt to come in and try to exploit this bizarre relationship that exists between the cable providers, i.e. the Wi-Fi carriers, on the one hand and the cellular providers on the other.
So, you can imagine hyperscalers like cloud providers could do it. They're not really doing it yet, but it's clear, and if you read the sort of the, industry rags, that a lot of the network management right now is actually being handed over to hyperscalers, the usual suspects that manage the cloud. So you can imagine them doing it, but generally they're not doing it yet. You could imagine actually service providers, current service providers, like the descendants of Mabel, doing it themselves. They definitely could. They sort of already have the customer base. Often they have very good relations with the customers, and they could provide these services, but right now they don't. You could imagine that the network equipment manufacturers could themselves say, all right, we've had a good run, but, if you can't beat them, join them. Let's figure out how to make our equipment work together with Wi-Fi in a way that's just going to reduce the, total cost of ownership for our customers. So all of them could. Right now, I think is sort of this little bit of an awkward standoff when you're trying to figure out, who's going to jump first. As soon as one person does, then everybody will.
So let's talk a little bit about the utilization of cellular generally. So yes, it's much faster, bigger roads, smoother. When I think about my phone, right, it's funny that we call this device a phone, right? Because a phone implies that I'm using it to talk. And that, I would imagine, pretty low bandwidth type of activity. And maybe I used it to surf the internet. And so, as a layperson at the surface, I would sort of think, well, is it really that big a deal? Is all this that big a deal? All I'm doing is having a few conversations. I'm surfing the internet and I'm sending a few texts. But then when I think about it more, I realize that, well, I'm doing more than that. I have home cameras that I tap into. Right. And even if I'm not at home and I'm actually using the cellular, I might just leave it turned on for a while. And poor Verizon has to pay for all that bandwidth utilization when I'm not even paying attention to it. And there's the whole idea of self-driving cars that they need to be connected to a network in order to not crash. So what are the industries and areas that, away from the actual cellular providers, that are going to be able to reach that critical point and change our lives by offering new capabilities and new services on the back of this very big bandwidth mobile data capability?
That's a really good question, Tony. And actually this will take me to a question of then what is speed? Okay, we've been talking about speed right now, sort of comparing it to cars. I'll use a different analogy if you'll allow me to change metaphors. And a lot of your listeners may be more familiar with that. During this whole pandemic, staying at home, a lot of people started ordering meal services, right? So if you think of ordering, your meals at home, you say you order 52 weeks of meals for a year, right? So insufficient rate would mean that you didn't get 52 weeks worth of food, okay? Speed is different. If somebody delivers you 52 weeks worth of food, but they only deliver it to you, say, every 4 weeks, then what happens is you did get enough food, let's say you got enough data, but a lot of it is old by the time you get to the end of the fourth week. And that goes back to this new desideratum in 5G that I was mentioning at the beginning of our chat of ultra reliable, low latency communications. But this low latency means that it also has to get there quickly enough, right? Suppose I need some data. If I want to, say, play a game or watch a movie, I only need so much data. Now, I still need maybe a lot of data, but, I don't need an infinite amount of data. I really need it to get there on time. Or if you're driving a car, you don't need infinite amounts of bandwidth. You do need the stuff to get there on time. And so a lot of the schemes actually that traditional 4G and even 5G to a large extent have been using are good at doing the reliability part, but they do it at the cost of putting lots and lots and lots of redundancy. And that really hits you on the delay part. So that has been a really big problem for the way I would say for 5G is being done now. So This gets back to what we said at the very beginning. What's the difference between actually, what's happening in standards versus this sort of informal definition of 5G, which is, hey, I want my data and I want it now. I need it seamlessly. I don't want to be messing around with connecting to this hotspot and that hotspot. And I want it to be very reliable and I want it to arrive exactly when I need it. So that's a big challenge right now, I would say, for the current 5G.
So what are the areas of the economy that are going to be the biggest beneficiaries once the 5G gets fully built out and meets its promise, if you will, from a data standpoint? Is it self-driving cars? Is it the electrical grid? What are the areas that we should be looking at just generically, as investors thinking about what areas of the economy are really set to benefit in the years to come as a result of the advent of this, massively powerful data network that is still in the beginning stages?
Yeah. So I would say I'm not quite sure how 5G is going to look. Okay. I believe the informal definition of 5G will happen. Whether it happens largely because of the 5G that 3GPP has worked on or only very partially, I think time will tell. So I want to be very careful when we talk about 5G. I'm really talking about the informal definition of 5G. One of the big drivers of traffic right now, actually, is not necessarily so much new applications, but is data due to machine learning. So analytics, a huge amount of analytics are actually creating the majority of the traffic increase. So this is not from customers or new services coming on. That's not where the bulk of the traffic is coming.
Is it financial analytics? Is it healthcare analytics? Is it social media analytics?
All of the above, all of your advertisement, all of those analytics are actually, they're the lead item, they're the first order factor.
So the whole system is a self-perpetuating beast in a sense.
Indeed, exactly. I mean, as you were talking before, you said, hey, here's my phone, but actually I'm not really using it as a phone all that much. I'm using it more as a handy little laptop, in effect. Now, the question is now, who's paying for that? As you were mentioning before, to some extent right now, you're paying for data that is basically being used by a hyperscaler to sell you stuff. It's a business model that sort of leaves the door open to a lot of people to come in and do some arbitrage.
And what about this idea of 6G? Is it going to be as revolutionary and important as 5G was? And when is 6G going to happen? Because we're still talking about 5G just getting off the ground.
I would say 5G is very mixed. Some parts of it, like particularly the high frequency things that I mentioned, and some items around some of the antennas, what's called MIMO, multiple input, multiple output, massive MIMO, lots of antennas. That is pretty advanced. A lot of other parts of 5G are not advanced, are not particularly advanced at all. Particularly the redundancy I was mentioning to you before. So I think that, if you look at 5G really from a technical perspective, it's a mixed bag. A lot of the people who are now saying it's very revolutionary, have a dog in the fight, right?
Right, yeah. They want to commercialize it. But so 6G is going to come along and fill a lot of those gaps, I guess. And what's the time frame on that?
That's a good question. Obviously, we're already having discussions about 6G. It's unusual to already have the next generation being discussed when the previous generation is really not all that deployed. One of the questions that you can ask is, at some point, do you stop having Gs? Why do we really have these sort of discrete numbers every 10 years? It's not because you have a natural evolution of technology where every 10 years something fantastic comes along. And I think, one of the things to remember about 5G is that this has been a network equipment manufacturer push. This was not a pull from the network service providers. Okay, so the network service providers were not screaming for this by and large. Sure, they always wanted some improvements, but they were not asking for the next generation. They weren't saying, our customers are screaming for this or that or the other. The network equipment provider said, hey, it's time for the next G and you guys should be buying it.
And what about, you've used a term around 5G in our previous conversations, Muriel, about the idea of this being a generation that's vertically integrated. What does that mean?
So we didn't mention it specifically, although we sort of mentioned it obliquely, because again, having automotive, having robotics, having healthcare, these were a lot of systems that were generally very standalone. So 5G very much has a desire to do vertical integration, and that's a big difference between 5G and any of the other previous generations. So that is also part of that excitement that I mentioned at the beginning, being able to have all these services in an integrated fashion. But it also means that it's a very, very high hurdle, an unprecedented high hurdle for the technology to clear.
Can you give me an example of what a vertical integration would look like?
So for instance, let's take automotive. You mentioned self-driving cars. So this would be a system where the same network is managing the self-driving car and say, other services that are being offered inside your car. For instance, there's something called the edge of the network, which is all of the nodes that are sort of close to each other physically in proximity and may not use necessarily the 5G network per se to communicate with each other. So it's like this combination of the local and the global all under the same umbrella, rather than, say, having one system that's just making sure that you don't bump into things, which a lot of cars, high-end cars already have, and having another system that's making your phone calls for you, and having another system that's maybe
right.
Connecting to a satellite service for emergency, as opposed to having all those three systems be separate, and maybe you even have a small Wi-Fi network on your car so that your kids can watch whatever they want in the back while you're driving around, rather than having all of those be standalone, that those are all integrated.
There's one last question I do want to really ask you about, which is, it's not really a scientific question per se, I don't think. It's more of a geopolitical question. Mm-hmm. So back in the prior administration, the administration was very focused on making sure that the Chinese didn't get into the build out of the infrastructure, not only in our own country, because it was felt that 5G was so important, if it wasn't controlled by Western companies, that it would create significant security risk and such. How do you react to that whole sort of ecosystem of thought?
So let's go back to 3GPP. If you look at the roster of the companies that were involved there, say 10 years, even more, 20 years ago, and you look at the roster now, you can see that certainly the footprint of the US has decreased. You do have a case where particularly the US in sort of traditional telecommunications does not have, relative to the rest of the world, the same footprint it did, right? There's also a lot of health in some of the parts of the industry. I would say there's a lot of health in, I mentioned the parts that say deal with Wi-Fi. There's a lot of health in the parts that are doing what I would call the close to the hardware technology, what we usually call, the physical layer. There's a lot of health over the top, the hyperscalers, of course, that the US has a lot of strength.
Is there any respect in which we're confusing, commercial hegemony or the idea that we may not be dominant in areas where we have been historically, we being the United States, with valid autonomy or security concerns? In other words, is the latter masquerading as a pretext to try to maintain the former, or is it rather that there's more competition but that competition doesn't mean that we are fundamentally losing control of the security of our system?
So my view is that one should be treating systems as not secure, by and large, regardless of where they come. Because even if you trust your supply chain, do you really trust that everybody's doing their upgrades properly and that all the operations are correct? We talked about the importance of Wi-Fi. Okay, maybe you're worried that, some nation state has put in something in the equipment that's in the network. My local coffee shop I go to because, they're lovely and they make a nice cappuccino. I don't go there because they have the best hygiene with respect to updating the Wi-Fi router, right? At least one way to reduce that concern. I'm not talking about whether the concern is warranted or not, because that's outside my expertise. But I'm saying that one way of reducing that concern is actually exactly doing what we talked about earlier in our conversation, Tony, which is that if you actually connect to multiple networks at once, on purpose, not just because that's just the most efficient and, economical way to connect, which is just use all your resources. If you do some mathematical schemes around it, it's called coding, you actually also secure your system. It's actually very interesting.
Everybody needs to have self-responsibility for their own safety and security. They shouldn't rely on the system. They really need to be proactive in this environment of ransomware. And the fact that more and more of what we do in our lives, in fact, indeed invokes data and the transfer of data. And it just means that this is even more important because we're more reliant on the safety of that data.
I think service providers need to be responsible for providing this. I don't think this is something that you can expect customers to be doing this. But I think service providers, whether they're the current ones or the ones that will emerge on top, if the current service providers don't keep up, which, like I said, I think they can, but they will need to hurry up. That would be that will be for them to do. I think that should be part of the reliability. If you want to be vertically integrated and you really want to be part of the critical service infrastructure, then I think you need to provide that level of security. That I think those go hand in hand.
Fascinating. Well, we're going to have to leave it there because we're out of time, but just terrific insights. Let me try to summarize, as I always do at the end of the episode, 3 key takeaways for us. I think I'd start with the idea that there's more to 5G than meets the eye, if you will, which is to say that 5G is not just about speed. It's not just about latency. It's about a whole ecosystem of carrying data that meshes with another ecosystem that's critical, which is Wi-Fi. The interaction between those two spheres is quite critical in understanding where the commercial opportunities are going to be going forward, as in fact we see one borrow from the other and rely on the other in such deep and profound ways. And so 5G can't really be understood in isolation. It needs to be really understood as it relates side by side to Wi-Fi. Second thing is that we've talked a little bit about this idea of vertical integration, the idea that 5G is a system that allows for a much more complete delivery of an ecosystem of data management, in a sense, but it also creates a lot of risks around security and around dependency on service providers, et cetera. And it's really important that we hold those service providers accountable for the safety and security of data. So that's a complex equation of ideas there I'm putting together, but as the 5G providers become more important and do more things for us in an integrated way, it also creates more risk for us, and we need to make sure we manage those risks, and we demand a lot of those service providers in that way. And then lastly, I would say that the investment implications for 5G are indeed far-reaching. It's not just the relationship between the cellular and the Wi-Fi providers. Obviously, there'll be more reliance on them as we use more data, and there's more investment opportunity potentially in those core providers. But even beyond that, when we think about industries like self-driving cars and healthcare and big data and analytics that all use these rails, if you will, of data, or security companies that provide the right kind of security that may not be provided by the service providers today and need to be overlaid. And these are opportunities that we as investors are thinking about every day as we build out portfolios. So, Muriel, I want to thank you again for your terrific insights. We could have just gone on and on today, but I've really enjoyed the conversation.
Thank you. So have I, Tony. I really appreciate the discussion, really appreciate the invitation, and I really had fun talking to you.
Thank you so much. I encourage all of our listeners to visit wilmingtontrust.com for a roundup of all of our latest investment and planning ideas. And you can subscribe to Capital Considerations on Apple Podcasts, Spotify, Stitcher, or your favorite podcast channel to ensure you get updates on future episodes.
This podcast is for information purposes only and is not intended as an offer or solicitation for the sale of any financial product or service or recommendation or determination that any investment strategy is suitable for a specific investor. Investors should seek financial advice regarding the suitability of any investment strategy based on the investor's objectives, financial situation, and particular needs. The information on Wilmington Trust's Capital Considerations with Tony Roth has been obtained from sources believed to be reliable, but its accuracy and completeness are not guaranteed. The opinions, estimates, and projections constitute the judgment of Wilmington Trust as of the date of this podcast and are subject to change without notice. Wilmington Trust is not authorized to and does not provide legal or tax advice. Our advice and recommendations provided to you is illustrative only and subject to the opinions and advice of your own attorney, tax advisor, or other professional advisor. Diversification does not ensure a profit or guarantee against a loss. There is no assurance that any investment strategy will be successful. Past performance cannot guarantee future results. Investing involves a risk, and you may incur a profit or a loss. Any reference to company names mentioned in the podcast should not be construed as investment advice or investment recommendations of those companies. Facts and views presented in this report have not been reviewed by and may not reflect information known to professionals in other business areas of Wilmington Trust or M&T Bank, and may seek to provide financial services to entities referred to in this report. M&T Bank and Wilmington Trust have established information barriers between their various business groups. As a result, M&T Bank and Wilmington Trust do not disclose certain client relationships or compensation received from such entities in their reports. Investment products are not insured by the FDIC or any other governmental agency, are not deposits of or other obligations of or guaranteed by Wilmington Trust, M&T Bank, or any other bank or entity, and are subject to risk, including a possible loss of the principal amount invested. Wilmington Trust is a registered service mark used in connection with various fiduciary and non-fiduciary services offered by certain subsidiaries of M&T Bank Corporation, including, but not limited to, Manufacturers and Traders Trust Company, M&T Bank, Wilmington Trust Company, WTC, operating in Delaware only, Wilmington Trust N.A., WTNA, Wilmington Trust Investment Advisors, Inc., WTIA, Wilmington Funds Management Corporation, WFMC, and Wilmington Trust Investment Management, LLC, WTIM. Such services include trustee, custodial agency, investment management, and other services. International corporate and institutional services are offered through M&T Bank Corporation's international subsidiaries. Loans, credit cards, retail and business deposits, and other business and personal banking services and products are offered by M&T Bank, member FDIC. 2021 M&T Bank Corporation and its subsidiaries, all rights reserved. Private market investments are only available to investors that meet the U.S. Securities and Exchange Commission's definitions of qualified purchaser and accredited investor.